Okay, so what I'd like to look at here is the tangential acceleration. This is what we usually think of when we think of acceleration. This is speeding up and slowing down. So that means a force that's applied in the direction of the object, in the direction of travel, excuse me, speeds the object up. Okay, so if something's pushing you from behind or pulling you from ahead of you, it's going to help make you go faster. It's going to make you go faster if you do that. That sounds reasonable, right? And then the converse is, or it's not the converse, maybe it is, a force opposing in the opposite direction tends to slow an object down. Okay, and that also makes sense. If you've got something pulling you from behind or pushing you from ahead, you're going to slow down, right? Makes a lot of sense. Mathematically, what we'd say is the acceleration, which we previously said was the net force, the sum of all forces over m, is equal to the change in the speed now over the change in time. So this is the time of application, time forces applied. And this is the change in speed. Okay, so that means the unbalanced part of those forces will either speed it up or slow it down, depending on the sign. So if the sign of the mass is always positive, so if the sign of the sum of the forces is negative, it's going to slow you down. If the sign is positive, it will speed you up. So this is your acceleration, and these are your forces. This is the sum of all forces. Okay. And what the deltas mean is just the change in. So that's Vf minus Vi over Tf minus Ti. Something like that. So that's what we're going to look at. Again, think about this as something pushing you or pulling you. So let's say you're going to, I don't know, run into the wind, right? If you're running and then a wind hits you, let's say, usually for me that's when I go around the corner, that makes it hard and you're going to slow down, right? But if you're going the other way, it never feels like it's equivalent, but if you're going the other way, then the wind is pushing from the back. If you get some sort of tailwind, it's going to push you forward. It's going to make your life easy and speed you up. Yeah, and that's all that's happening here is a new force is going to speed you up or slow you down from your original direction of travel. So all we're saying is that if this number is positive, if A is positive, then this change is positive, which means you speed up. If this change is negative, then, or if this acceleration is negative, then this change is negative, and that's going to slow you down. Right? And it's only going to last as long as the force is unbalanced, excuse me. All right? All right, example next.